Am I audible? I didn't start yet. All right. Very good morning to all of you. I hope everybody is fine. Well, the good thing is that we are ending our syllabus soon. We are left with session, presentation, and application layer. And I believe this week we'll have our first quiz as well. After quiz, give one more assignment, one more quiz, and we're done with our syllabus. I have got some questions, well, but not that many for the previous classes that we have. And I hope I have cleared the doubts. In case you still have any questions, please go ahead, email me. You can unmute your microphone and ask me now, or you can just type in your question in the chat box. Okay, Ramanand, am I clear? Audible? Okay, I'll still stop my video just in case there would be any lag. All right, now if we go from bottom up approach, transport layer is given data by the higher layer, that is the second layer. So we have fifth layer from bottom up approach, which is session layer, then presentation layer, and then we have application layer. And if we talk about OSI layer, we have fifth, sixth, and seventh layer as session, presentation, and application layer. However, if we compare this with TCP/IP model, reference model, then these layers are combined together. So we have 5, 6, 7 combined into a single layer, that is the application layer. Why? What is the reason? Well, they have some functionality which are optional functionalities along with the presentation layer, and they have work that is very limited. And the session layer here is the thinnest layer in the OSI model. So we have session layer residing above the transport layer. And these layers, typically session layer, is supposed to provide a value added service to the underlying transport layer service. That's why we call it as optional service. What do we mean by value added service? Let's say you have your telephone service, mobile service, right? When you go and buy it, you get the phone, you get the connection, you get the SIM card, that is a physical device that you get. You put in the phone, you can make the call and so on. So by making the call or sending the SMS, okay, you can actually get the connectivity. That is what mainly you require from the mobile services. But then they can provide you some more services, like, do you want a caller tone, right? Do you want let's say data services? Do you want different other services? Okay, which are optional services. I'm just giving an example here, which are optional service, which actually would not alter with your communication, with your mobile communication. You can still talk and SMS without having these kind of services like caller tone and so on. Likewise, the session layer as well as the presentation layer that we are going to discuss today add this type of value added services, which may be or may not be of use to the applications. So if an application needs session layer services, it would use it. If it doesn't, it would simply pass on the data from the application to the transport layer. So this is what we have, the sender and the receiver. Data from presentation layer would be passed on to the session layer, where most importantly synchronization will be done. And then from session layer it will be passed on to the transport layer. On the receiving end, the data from transport layer would be passed on to the session layer, where synchronization would be done, and from the session layer it would be passed on to the data to the presentation layer. So synchronization between the two session layers would be done here. The upper three layers, that is the application, the presentation and session layer, they are known as upper layers. Let me just, they are known as upper layers. Why? Because these are responsible for applications communicating between hosts. They are not concerned between networking, network address. Okay. Why? Because in the last class I told you that the transport layer provides the abstraction of how this data is to be sent, the fragmentation, the breaking up and so on. That all is taken care by transport layer. It covers it up. Then what? They are only there to provide value added services to the underlying transport layer service. So they are not concerned with the networking, network address, and so on. And what value added service do we talk about here? The session layer is where actually the connections are established, the connections are managed, and the connections are torn down. Okay. So here we can say two things. One is session oriented communication and session less service. Or or another example I might give you here. Let me just type in here. I would say session oriented communication versus connection less conversation, or session less conversation, what we to understand this session oriented and session less. Let's say you have a telephone. Okay, you call a person you want to talk to, you dial the number, you establish a connection, which in our case here means session. Fine. Then you finish the conversation, you hang up, and then you say your conversation is complete. When you hang up, you are tearing down the connection, you are completing the connection. That is where session is complete. This is what we have as session oriented communication. You can compare this with connection less conversation. And what is connection less conversation? You have a walkie-talkie, right? What is walkie-talkie? A device in which you just simply speak in, and you hope that the other person is listening at the other end, and they would also call back. I mean, they would also speak back in the same kind. In the case of walkie-talkie, no session is established, whereas in case of telephone, we have a session established. Now, why do we need basically sessions? I will come to the function of it, but keep here in mind that we need sessions. I can just write this in red. Session is used to keep track of individual to remote servers. Okay. The example of, I'll just write here, the best example or an excellent example of sessions is your browser. Web browser is an application layer object. Okay, I'll take it take of browser in a little while. Let me just clear this. Okay. Now let's see. Some common protocols that work with session layer are DNS, LDAP, NetBIOS, and so on. Okay, LDAP is a directory protocol, as we have discussed previously as well. What directory protocol is LDAP? It's lightweight directory access protocol. It's actually a client server protocol which helps in accessing directory services, right? It runs over TCP IP generally. Another example that we see in session layer protocols are NFS, that is basically these are application layer protocols which work with session layer, network file systems, SQL structured query language, you know very well, you've studied this in database systems, remote procedural calls, RPCs, you studied this in operating system as well, in which this is used, for communication between, different systems, typically client server and so on. Window, it's an intelligent terminal for communicating with remote Unix computers, basically a remote login for Unix systems. And now we have the session layer services. And the services that session layer provides include the first one as dialog management, the second one as synchronization, the third one as activity management, and the fourth one as exception handling. Let's take them one by one. The first one, that is the first session layer service that we have here, is dialog management. So in dialog management, what do we have? It's like, who will be given the chance to speak? Why do we need this? We understand that all communication cannot be bidirectional and full duplex, right? There are some operations which work in half duplex mode. And what is half duplex mode? The sender as well as receiver cannot speak simultaneously. Okay, they cannot send the data simultaneously. It has to be one of them. First the sender or the receiver who speaks, then the other party. So when one stops speaking, the other one starts sending. That is what we have as half duplex mode. And now we would require here a mechanism which is known as dialog management, in which, okay, in which the session layer gives a chance to each and tells whose turn is to send the data. How it is implemented? The dialog management is implemented using a token known as the data token, which has been mentioned here. And what is this data token? It's like a green signal. It's like a green card. All right. You have this card in your hand means you should be able to speak. In other words, if this token is with the computer, means it can transmit the data during that time. And this token moves between the senders and the receiver. So now if the other party has the green token, I would be quiet. I would have to just listen, which means that the other end receiver would be sending this time and I'll be only receiving. Whosoever possesses the token would actually be transmitting the data. So I would like to add a few things here. Is in the dialog management. That is that dialog can have three forms. what are those? The first one we understand is simplex dialogue. And what is simplex dialogue? One-way data transfer. What is the example of one-way data transfer? Your TV receiving the signal from the tower. You cannot reply back to the signal. Fire alarm, which sends a message that there is a fire. You cannot reply back to it. It's just that you receive a message. The second one is half duplex dialogue. And what is this half duplex dialogue? We have two-way, which I just now explained, but data flows in one direction at a time. So when one device completes the transmission, the device must turn over the medium to the other device so that the second device transmits, so that the other device gets the transmission. This is what we took the example just now as walkie-talkie. And the third dialogue that we have is full duplex. And what do full duplex dialogue? It permits two-way simultaneous data transfer. Two-way simultaneous data. So it's a bidirectional transmission, and it can happen at the same time as well. It, in other words, uh, data transfer or mechanism for data transfer with for each device as a separate communication channel. Telephone that we use are full duplex devices. So you also speak, I also speak, should be fine with it. So what do we have here? We have here the session layer managing these dialogues that we have here. So control and manage multiple this bidirectional messages is done by dialogue control. So session layer does dialogue control, and what it does is control and management of multiple bidirectional messages. This is basically what the dialogue management does. All right. Any questions about this dialogue management? You understood how it is done with the help of a data token. And what is the data token here? It's if you have this data token, you are allowed to transfer the data during that time. So ISO protocol data dialogue management is implemented through the use of data token. So, data token is sent between the sender and receiver. So it's sent back and forth, and the user would transmit only it if it possesses this token. So we move on to the next one, that is synchronization. And what is this synchronization? Let's understand synchronization. So let me explain it in a simpler way. We have session layer marks the data stream. The session layer marks the data stream. How? with checkpoints and monitors. So we have session layer doing synchronization. And what does it do in synchronization? Basically, it would mark it with the help of checkpoints and monitors. So it puts a checkpoint and monitors the receipt of those checkpoints. Let me explain it in this way. Then we'll discuss the previous slide. Let us say you are downloading a file, let's say from FTP, okay, which is of this size, 100 MB. Now, while downloading, suddenly your connection had an issue or you got disconnected. What would happen? You would lose the data. You would have to download once again all of it. But here, session layer can help us. What this session layer does is it will break this it will break this 100 MB into smaller partitions. Let's say it will, for example, break this 100 MB into 10 partitions. Each will be of 10 MB. So I'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. Now, session layer breaks this 100 MB into each block of 10 MBs. I'm just giving an example. And it puts a checkpoint after every, let's say this is the first checkpoint. Let's say if it's starting from here, so if it's starting from here, this is the main. So we have a checkpoint after every 10 MB. So what would happen in this case? If we use synchronization and you're downloading this file, you have downloaded, let's say you have reached up to third checkpoint. Now you are here downloading at this specific point and your connection got cut. Now you reconnect again. This is where session layer would help. It would, rather than downloading it from the beginning, okay, rather than here and starting the download, what would it do? It would continue with the last successfully received session, which in this case would be from here number 3, and continue downloading the rest from here. Only the lost part would be this much, that is from checkpoint 3 to checkpoint 4, which is a smaller amount of data as compared to the overall that it has downloaded. Just imagine like you are downloading and you have reached 99% and something happens. You're supposed to re-download whole of the thing if session layer is not there. So session layer, what it does, it creates checkpoints and it monitors the receipt of those checkpoints. It says, okay, this is received, this is received, this is received, this is received until it reached 9. And here it was a failure. What it does, it continues from ninth or the last received checkpoint and it would have to download only this much. So in the event of failure, the sending PC can retransmit starting with the data sent after the last successfully received checkpoint rather than resending the whole of the message that we see here. Do we get it? You can say, but we had error checking, we had other things in the lower layer. We had error checking in transport layer as well, right? Communication layer. Yes, transport layer handles the communication errors, but synchronization here deals with upper layer errors. Let's say, let me give you an example of what kind of errors we can have here. Uh, As an example, in file transfer, the transport layer might deliver the data correctly. So all the layers did error checking. There was, internet checksum done by the transport layer also. But once the transport layer passed on the data to the application layer tried to receive it and save it onto the disk. However, the disk was full. So there is no issue up to the transport layer. There is no issue with respect to errors or anything else. Data is all right. But the problem is it cannot be saved by the application layer. This is what an upper layer error can be. And this is where synchronization can help. So users can split the data stream into pages, insert these checkpoints, which are known as synchronization points between each page. When an error occurs, the receiver can resynchronize the state of a session to a previous synchronization point. This would require the sender to hold the data as long as it may be needed until it's successfully transmitted. So we have synchronization achieved with the help of these checkpoints or synchronization points. And synchronization is achieved through the use of sequence numbers. We would have here, like I mentioned, 1, 2, 3, 4. I would have sequence numbers which help me in synchronization. So I'll go back to the slide here and let's see what it says. I have explained it in simple terms. So synchronization here says that transport layer deals with communication errors, which I just mentioned, whereas synchronization deals with upper layer errors. The ISO protocols provide both major and minor synchronization points. When resynchronizing, one can go back as far as the previous major synchronization point. Like I just mentioned, that we'll go back to 9 rather than going back to 0. And this mentioned here major and minor synchronization points. What is major and minor? Major synchronization points are acknowledged through explicit message. You use messaging to say, yes, I have received this synchronization point. It's a bit expensive because you would need separate messaging for this, as compared to minor synchronization point, which are just markers. Then we have the third one as activity management. Oh, Dialog before the dialog. Let me add one more here, that is sessions, session management. Let me just add here sessions. So what we have sessions here, session layer providing actually sessions. The session layer defines how to start, control, and end conversation. Start, control, and end conversation. What we mean by conversation here, conversation means sessions. And who do we have these sessions in between? These sessions are between applications. This sessions or session layer tools are provided through APIs, right? This also provided through APIs or application programming interface. Now, commonly available or common APIs include NetBIOS, TCP IP sockets, RPCs, remote procedure calls, which we have discussed in the previous subject. Most of these, protocols using these APIs are of the interest of developers of application software. For example, the socket interface lies conceptually at this layer and is used by TCP IP application programmers to create these sessions between software programs over the internet. Likewise, we have Windows Socket also, which helps the Windows software programmers to make the applications internet capable so that you can send and receive the data across the internet or across the applications. Another thing that sessions help us, which I mentioned, is that it helps us to keep track of individual connection to remote servers. I gave an example of web browser. If you remember in the previous course, when we took an example in which we had a web browser as an application object, you open a web page. The web page can contain text, it can text, it can create graphics, it can have different objects like Macromedia, Flash, Adobe, and PDF, and so on. It can have different objects at different places, right? So these all objects, text, videos, graphics, pictures, they are stored as separate files on the web server. And to access them separately, we can, to access them, a separate download must be started. Remember multi-threading and so on, which we took in operating systems. That is what we have here. Now, browser here, when it has to separately download each of the object or graphics or text or video, it has to have a separate session to the web server to download each of the individual files. So this is what a session is supposed to do. It is supposed to keep track of these individual connection to remote servers. Even though it is an application that is a web browser, let's say for example Chrome, even though it's a web page that is one site, that is Facebook, for example facebook.com, but it will have pictures, it will have text, it would have video, it will have graphics, it will have other objects, and each of them would create a separate session to the Facebook web server, and each of them have to be downloaded individually. How does in operating system, remember, if it takes time to download the video, but at least text is downloaded. One thread would not block the other thread. They would be separately taken care of, right? That threading concept. Now relate it with sessions here. And sessions would keep track of which packet and data belongs to which file, so that graphics doesn't go to text, text doesn't go to video. It keeps track of where this data is supposed to go. In this case, our web browser. In the web browser, to which part, to which object it has to be sent. That's why TCP/IP typically in today's modern internet applications, the session, presentation, and applications are all combined together, usually rolled together inside the application itself. And our browser performs the function of application layer. It performs our browser is an application itself, but it can perform the function of an application, presentation, and session layer together. Okay, it would have then the TCP/IP functionality to this application software, which will give internet facility to it, which I mean to say that it can give remote connection to a remote machine. Then it can have different local port numbers with the help of a transport layer. So this is what we had as sessions. So I move on to the and after, so we have first one as sessions, then we have the dial, then we have synchronization. Now I have activity management. Any questions till now? You can send a text, you can put a chat if you have any questions, or you can just simply ask the question. Any questions? I hope it's clear why we need this session layer. Our book might not have, separate session layer explaining this all. So it's important to understand what are the functionalities here separately for the session layer. Okay. So the next service or the function that the session layer provides as activity management. And what is activity management here? The activity management allows the user to delimit the data into logical units known as activities. Just underline here, activities. And then each activity is independent of activities that come before it or an activity that comes after it. This also means that activity is processed on its own. So activity here is given an example, may be used to delimit the files, a multi-file transfer. This LES, this is here files. To delimit files of a multi-file transfer. Here it's multi-file transfer. Okay. These activities are also used for quarantining, collecting all the messages of multi-message exchange together before processing them. Here we all understand what quarantining is presently, right? So I might not be able to, I might not need to explain what we mean by quarantining here. And then collecting all the messages of multi-messages exchanged together before processing them. And then the receiving application would begin processing messages only after it has, taken all the messages, only after it has, all the messages are arrived. What does this mean? Let me explain it in simple terms. This means all or none of the operations are performed. This ensures that either you do all or do none. And where do we require this all or none? Can anybody answer it? Yes, you can unmute your microphone or you can just reply in the chat. Transactions. Now, Nawazish, very good. Nawazish has answered it well by saying transactions. So, as an example, Nawazish plus one, remind me. As an example, a bank transaction, may have, this is typically what you have studied in RDBMS, right? That you would want either complete transactions or no transaction at all. You might have taken the example in RDBMS in which you know you have to transfer some amount from one account to another account. So how do? You check first account, yes, money is available, deduct that much of account, then check second account, if it's there, then add that amount to the second account, and then you have the resultant transaction done. Then when you discuss about is, remember atomicity and so on, you say that, well, transaction is being done, it's a stepwise process. You have task 1, task 2, task 3, task 4. You would want that these tasks are all completely done, first, second, third, fourth. However, if in between there is some error and the transaction could not be completed, what do? You roll out, you roll down, you go back to what was the previous state before this transaction was done. This is typically what we use for bank transaction, which may consist of locking a record, updating a value, and then unlocking the record. If due to some network failure, if we couldn't do, this would create a problem. And that is where the session layer would actually help us in activity management. Okay. It would reset the operation in case of a failure. If you could not complete the remaining of the task, go to the previous state, go to the initial state, roll down, roll out, roll back. Actually, the best term would be roll back to the previous state and start all over once again, once your connection is okay. This is what we have as activity management. And also, we have exceptional handling, which is for general purpose mechanism for error reporting. Like I mentioned, that there are, errors which can happen at the session, application layer as well. What kind of errors? You receive the packet, it is fine, it is clear, it's sound, it's error free. But while sending it to the disk, it could not be saved. Since it could not be saved, so what do you do here? You would simply, right, say that disk is full. This is the error which is generated by this layer. And as an example we took previously in session was, as an example of protocols, we saw that some common protocols which work at session layer are DNS, LDAP, NetBIOS, fine. And also example of session layer protocols is RPC, which basically shows the connection or remote procedural calls. So RPC provides a different paradigm for accessing networks. So we have studied this RPC in the previous course, so I believe you should know it by now. Still, in this PPT, it is written how do we make this remote RPCs? What is the main goal of this RPC? After this, we have the next layer, that is the presentation layer. I'll be taking that in our next class. In the meantime, I'll send you links where you can go back and have a look at the congestion control mechanism of the transport layer. Have a look at that as well. Okay. Do you have any questions? Ramanan, please take the attendance. Any questions? No? Ramanan, should we end the class then? All right. We are also planning to have a quiz and preparing the questions. So it will be again MCQ. So please be ready for that. I will take up the syllabus up to the network layer, and network layer is included. It will be whatever we have discussed in class, the assignments as well as the tutorials, the notes and the video links that I have provided to you. That all would be covered. All right. I'll see you in the next class and thank you.